So hi and welcome to this session on SUSE Virtualization on AWS. So I'm Stephen Mogg, I'm a Public Cloud Solutions Architect here at SUSE, and I'm privileged to be joined by both Dominic Vonbacher, who's a Partner Solutions Architect over at AWS, and Graham Hares, who's a JSI Solutions Architect here with us at SUSE. Now, for those that are coming into this session, we really don't want to give you the impression that running SUSE Virtualization on AWS is in any way supported, okay? It's not, and AWS support for SUSE Virtualization isn't even on the roadmap at this stage. So this session and its content really is just for fun. And of course, maybe it's going to help you have a go too. So I guess if you're on the telly, we'd say something like, don't try this at home. But in this case, it's not true. We really do want you to try this at home and experiment. But maybe just don't try and run your production business on it. So we've got a packed 25 minutes during which we'll spend a little time discussing what SUSE Virtualization is, why we want to run it on AWS in the first place, and then we'll get into the detail with Dominic and Graham, who share their experiences of getting this running on the AWS cloud. So what is SUSE Virtualization? So SUSE Virtualization, or Harvester, it's a cloud-native virtualized platform on which you can run virtualized machines. Now, this isn't a traditional virtualization platform which you might have been used to over the last 20 years or so, but it takes a series of open source projects such as KubeVirt, KVM, and Longhorn to provide a virtual compute storage and networking environment. And of course, it's got Kubernetes at its core to provide an orchestration layer. Now, the idea is that SUSE Virtualization can support any x86 workload, such as Linux or even Windows if you want to. And of course, you can even build Kubernetes clusters on top of that if you need to as well. Now, the key thing is it's been designed to run on bare metal, so with real hardware, real networks to connect into and so on. And it actually has an appliance-like installation to run, so you kind of boot off an ISO or Pixie boot or something like that to get the instance up and running. And also have this concept of clusters as well. So during the installation, you can either create a new SUSE Virtualization cluster or join an existing one if you want to. And then the whole thing is fronted by a pretty easy to use UI. Now, from an architecture perspective, at the bottom, you'll find SUSE Linux. And on top of that, we've got the things like Longhorn and KubeVirt, which you mentioned already. And on top of that, you can deploy virtual machines. Now, by default, these virtual machines will deploy and connect into a management network, which is a kind of like a Kubernetes overlay network, and all the VMs can see each other there. But it's also possible to create VLANs if you need to. If you want to isolate specific machines to certain subnets, you can do that. And you can have VMs attached to more than one network if you need to do that. Now, by adding further physical nodes, you can actually build out a SUSE Virtualization cluster. And what this does is it allows administrators to manage the whole estate as if it were a single platform or a single pool of resources on which to either run VMs or container-based workloads. So I guess the question is, why might you want to run this on AWS in the first place? Well, of course, the obvious one is testing. All right, so maybe you want to play with SUSE Virtualization, but you maybe don't have the suitable hardware in order to do the testing on and install it properly to take a look. Maybe you've got SUSE Virtualization running in your own data center and you want to extend some of those workloads into the cloud. And rather than manage two discrete platforms, we could potentially have one consistent experience for those VMs in both places. Now, again, a gentle reminder that a hybrid is not supported as a scenario today. And of course, finally, there's the migration scenario as well. So if you're closing out your data center, this could be a way of easily moving those workloads into AWS. Okay. Now, the question about why SUSE Virtualization on AWS, for everybody here, it was more about the challenge of just trying to get it working in the first place, right? Could it be done? And we had a few challenges to solve. So in terms of where we started, right, there are a few challenges we needed to look at. The first was how to deploy, and the second is what can we deploy on in AWS. Now, in terms of how to deploy, So again, think about how SUSE Virtualization is installed. You either boot off an ISO from a USB stick, or you can Pixie boot, but it's a very traditional boot method. You give it an IP address, a virtual IP address during that installation process, along with a whole host of other details. And that's something you just can't use or do in the cloud. So normally, if you want to deploy something in AWS, you have an AMI or an Amazon Machine Image, which has everything baked in, including drivers, suitable partition layout, all the packages you need, and so on, in order to get an instance started. And as for AMIs for virtualization or Harvester, there are none. Okay, so it's not it's not a supported way of working. So of course there wouldn't be any AMIs available. And then you can't really pixie boot either. So again, networking in the cloud tends to be an abstracted service. So you've got no real access to the layer 2 level of the network, which means we have to go and try something different. Now, as for what to deploy on, that's one thing we could actually solve pretty easily. So AWS has been providing metal instances for probably the best part of 7 or more years now, and SUSE has had a lot of support for those instances since launch. So the remaining challenges were either how to turn the ISO installation into something a little more cloud friendly, and for that it was time to find some clever people. So we've got two very different approaches, and at this point I'm going to hand over to Dominic at AWS, who tried to do things by the book.
Thanks, Stephen. So I'm actually not sure if I would call my approach by the book, but indeed. So I was thinking from a support perspective, so if the SUSE Virtualization team um, would like to run it officially on AWS, offer commercial support, so how they would tackle it, how they would going to implement it. And that's where I started to explore the right way, as you called it. And now we can take a look on my approach in more detail. So the idea is that, or let's start something with the wording thing, because you mentioned it earlier already. So we have SUSE Virtualization, sometimes we say Harvester. And this is because Harvester is basically the open source upstream project for SUSE Virtualization. So throughout my slides, screenshots, and even what I talk about, I probably refer more often to Harvester. So just that you don't get confused. So as initially said, my approach focuses on staying as close as possible to the official Harvester installation process. And if we take a look, the installer handles all these different aspects of deploying Harvester. So from petitioning, package installation, configuration, first boot setup. So as Stephen mentioned, it is kind of an appliance-based approach. And most importantly, all that installer thing prepares your system in a way and ensures that you have this proper upgrade capabilities, which is what we actually would need in future, because installing it once is pretty nice, but keeping it upgraded is even better. Um, and also from a technical perspective, so the installer leverages another open source project from SUSE, which is called the Elemental Toolkit. So some components are specific to Harvester, some things are then specific to this Elemental Toolkit. And while I was researching through that installer code, I discovered there is actually an undocumented feature to generate QCOW images. I basically stumbled across it during just a code search. I was really looking for things like image, QCOW, raw image, and so on in the source code. And then I found a pull request that names install mode. And interestingly, behind this install mode, there are actually a couple of features that introduce the generation of images, which is, it looks like a great starting point. And I thought, okay, it's already part of the official code base, and would probably be maintained and be compatible in future releases. So I took a closer look on that thing, which brings us to the technical implementation. And after taking a deeper look, I realized, okay, there are a couple of slightly modifications that I have to do to the installer code. Because first of all, I had to bypass the network validation that expects that networking is set up, a default route is available basically because the Harvester installer received IP addresses through DHCP. And this check was introduced after the install mode and unfortunately basically broke it. So I had to revert that. Because when you think about it, I mean, the installer runs in a temporary environment during the image creation, and networking isn't actually needed at that point. So it's fine to skip that for our scenario. The second problem was that I had to disable the pre-flight hardware checks. They do some verifications like vCPU count, RAM. Does the system I'm running on fulfill all the requirements for production-ready harvester installation? And for building the image, I don't necessarily have to have a host that ticks all these different boxes. And I think it's important to stress out again here. So what the Harvester installer actually does is it spins up a virtual machine, then does some sort of unattended installation, shuts it down, exports the image. So this is why I hit some of these check problems. And then last but not least, there was the thing that the Harvester installer generates the image and then just keeps the compressed version of that image, which is nice because it's not that large. But unfortunately, in the context of AWS and creating an army, this is a problem because I need it as an uncompressed raw image. So I just made a slight adjustment to keep that uncompressed image so it doesn't get deleted at the end. Overall, that whole process, so from checking out the code to having a raw image that can be then imported to AWS, that took roughly an hour. And the conversion workflow looks basically like uploading the raw image to S3, creating a snapshot from that raw image, and then registering it as an army, which is great. But let's take a look on the results and some learnings. And then we see first the positive thing, left side. Yes, I successfully generated an image. I had a QCar image with that modifications that I put into the installer. I could upload it, I could import it, register it as an army, but then unfortunately, I faced a couple of interesting technical aspects. So an AWS army requires that the root volume, the root snapshot, contains exactly one partition. And but the image that the Harvest installer generates has multiple partitions, system boot data, and so on and so forth. You should see that on the slides on that screenshot a little. So yeah, it is a bit more complex than it would be expected from an army perspective. And then also the boot process on EC2, or the boot process on EC2 works a bit different than Harvester might expect it. So there is a difference in how petitions are labeled, how devices are named, compared to an on-premise environment, which is understandable. So we can clearly see that Harvester has on-premise in scope. So there are just some minor things that are not perfectly aligned. And as far as I can tell, the petition layout is currently the largest roadblock to finish that create an army, boot from your army experiment. But that would require some architectural changes. Um, Maybe it could work when you um, after the generation, when you then change the image by extracting the root partition into a separate image and so on. But I think then we run into labeling and device name issues. So that requires a bit of tinkering in Harvester, which I didn't at that point. So this means we this was basically then the end of my part of the experiment. And what I like to share with you um, is these installer code changes that I did. I mentioned it and explained it earlier. A couple of changes to the image generation running. So if you're interested in taking a look, try it yourself. Feel free to scan the QR code. It's all in my in the feature branch in my fork from the Harvester installer. So it isn't much that is required. So it slightly changes, and then you can get to the same stage where you have an army, or where you have a raw image that you can use as an army, and maybe you're able to figure out the partition problem. So the right way, was it the right way? um, so while this approach didn't resulted in this working solution, and not because of the partition layout, I think it was a great experience, a learning experience, and it provided a lot of valuable insights into Harvester architecture and AWS requirements when it comes to custom operation system and armies. But as Stephen already mentioned, yeah, we still have Graham, and my thing is just not the end of our experiment. So let's hear from Graham how he tackled the SUSE virtualization on AWS challenge with a very different approach.
Thank you, Dominic. Okay, so I'm coming from a completely different approach. It was also something I started independently. I wanted to try and create a nice AMI with the binaries installed. So I had a requirement where because I'm a partner, a GSI partner solutions architect. I like doing enablement, creating labs, things like that, and what I didn't have at SUSE was the ability to give third parties access to all our great lab sources that we use internally. So, I looked at various options. I've got a lab set up at home, but, I can't set up multiple instances and things like that. So I thought, AWS has bare metal nodes. So maybe we could do something with that. So I did the same thing. I sort of went through this path of seeing if I could set up a Pixie server and, looking at all sorts of blogs and different bits of information and seeing if that was possible. And in the end, I thought, okay, so I'm never going to get that done. It's really just an appliance. I'm a consumer. I need to go through that interface to see what I can do. So my next idea was the AMI, and I created an image just inside a desktop client. I did I did this in July. We hadn't changed the product. It was called Harvester. So I did a Harvester install with the installer option of just install the binary. So it's laying the bits into the image. And so I went through that process. I extracted it as an OVA image. I uploaded the OVA image, which took quite a long time, to an S3 bucket in the region I wanted. And then I tried to use the AMI importer tool from S3. And I tried multiple times. I went around the loop a few times, trying different things. It was initially a SUSE micro image because that's the underlining OS inside SUSE Virtualization Harvester open source project. So I also tried SLAIRs as well because I thought maybe the converter facility didn't recognize the OS, and I wasn't quite sure how the micro AMIs got there because I'm not part of that team. But it didn't work. So I either give up or just think about another approach and just remember my end goal is not to have a production supported Harvester running on AWS bare metal. It was just to have some environments, some lab environments for people to actually be able to log in, try some, activities. I can sort of share some slides and things like that. So, interesting thing is that the installer docs, this is on an older version of the installer. So I was on like 1.3.1 or 1.3.2, I think, back in the summer. There's this developer mode installer doc, and it's for really just developers that are actually just testing out a certain part of the components and maybe not the whole thing. So I thought, well, that'll be a really interesting starting point. So I could start with provisioning my own RKE2 cluster, and then install all the operators. So just like a layered kind of approach, install the operators, CRDs, and then install Rancher, and then on top of that install the the harvester Helm chart to see if that would work. And it did, but it took a long time getting there. It was quite interesting. I had to add extra configuration to sort of add an add-on, all those sort of things along the way. And, at the end of the day, I was able to spin up a guest VM, so a guest instance. I think it was SLES in this, it's too small to read, but it was SLES in this instance. And then I was able to SSH to it from the underlining AWS host OS. And it was pretty exciting. I had that running. It was kind of a unreliable install process, but because obviously I'm looking at different components along the way, and sort of spinning it up, and there's various timing things that are going along. But I thought at least it could be something that I could show. So just to give you a little bit of an insight, if you're interested in looking at the long drawn out history, there is a repo there at the bottom of the screen. And, the idea for this is that whenever I'm spinning something up on AWS, I want it to be immutable because it costs money. It's a utility-based model. Sorry, Dominic. So it's a utility-based model. And, I want to spin it up quickly with automation, reliably, do whatever I need to do for however long that takes, if it's a demo for an hour or something, and then immediately Terraform destroy, and it takes it down. So I've only spent a couple of hours or whatever resource I was actually spinning up. And maybe if it was Harvester Labs running on bare metal, keeping the time to as minimum as possible. It's not something you really want to sort of get all ready the day before, then go to sleep and then travel to your destination and then do the activity and then go home and then actually destroy it after that. You want to do it sort of as tight as possible. So automation. And the idea was to write in Ansible, but Bash script is normally my stepping stone to getting to Ansible. I can get that far. So you can have a look in that repo. It's very modularized. The infrastructure side is the Terraform, and then I have the deployment side completely in whatever else that's going to be. So Bash at the moment in that repo. So there were a number of challenges. So firstly, the add-ons. What I did was I looked at my sort of very carefully production type install lab environment at home, where I've got 4 nodes running a SUSE Virtualization cluster. And I sort of reversed engineered all the different versions. So I looked at what was there, and then I found the appropriate resource to make it the same version to sort of mirror what we would have. So at least the experience of a particular version would, for these end customers that they were going to be trying it, would be sort of similar to what was actually there. And add-ons themselves were something that wasn't in the developer mode, so I had to create the manifests for those to overlay them. So I think I did 2 or 3 in the repo. So monitoring is one, for example. So adding the additional nodes, strangely, I think it's because there's some slightly non-standard annotations that are used in the code base for SUSE Virtualization compared to just normal RKE2, and they all need to be there from the beginning. So the idea is so typically when you install an application, you would spin up the cluster with all the nodes. That would all be finished, it would all be available, and then you would install your application. Whereas the approach that works very well with the appliance-based installer, with my manual sort of approach, I found it slightly unreliable to actually create one node all the way up to the app and then add a second node and let that sort of catch up all the way up to the app. And I don't know exactly what that is. I think as well it might be I only recently joined the company, so when I did this, so I wasn't quite familiar with how things were working in terms of engineering and their management of the branches. And I think actually maybe they were putting new features into the branch that I'd picked, which I thought was the pass branch, the release branch. So there could be some work to do to actually make it stable. I do believe it can be. It's just a matter of understanding those things. But, I'd just rerun it and it would work the next time. So VM networking, that's a bigger challenge, okay? So, the way it works is you've got this Linux bridge and, you've got, as Stephen was saying, about pixie booting all the layer 2 type operations and then all the VXLAN and things like that embedded in it. And it's really not designed to run in an AWS network environment. So I did do a few tests, which I'll come on to in a minute. But that was one of the bigger challenges. So we could have done a lab, but there's no testing VLANs or anything like that going to be happening in this approach anyway. Guest networking works when connected to the management network, and that's really because you've got like a NAT type operation working for the management network. So I couldn't create, well, I did create VM networks, but they didn't connect at all. I tried a few times, a few different ways, but eventually moved on. Also, another interesting little thing that I spent some time on was inside the Harvester UI when you're uploading your images. Typically you would have an image on your desktop file system and you just click upload. But that didn't work. And looking into it a little bit, realized that there was some limitation of the size that you could do that file upload. I think it's probably good for security and other things. So I had to get the SUSE Virtualization to pull the image. So if you specify URL, which is the other option, then it pulled the larger images down, no problem. Just be aware of that if you ever do try it and you wonder why. So the last one was kind of interesting. So Harvester has a really nice VIP for its management consoles. This is the Harvester one, not the one that you would typically use, which would be your upstream Rancher Manager, which would then have all the benefits of RBAC to connect through to multiple underlining SUSE Virtualization Harvester clusters. So this VIP is a floating IP, so it's a virtual IP on one of the VIPs, and then if you shut that node down, the VIP would jump to another node in the cluster, and you would still have the access to the desktop. So I tried some interesting things with Terraform. I actually added a second IP onto a different network interface inside each instance, and then I found that I could manually connect in, disconnect that IP, deconfigure the network interface, and actually assign it as a second IP on an active NIC, and that worked really well. It was obviously manual, but it was just what's the art of what's possible to do it. So it was a very interesting project, but I think at the end of it, it's really not a production option. It was a very interesting lab exercise, and the benefits for me personally was to learn more about how the product's actually put together, what are all the different components, what is all the configuration at each stage. So that gave me a really good in-depth understanding of how things were all put together. And then I was very happy to join the project with Stephen and Dominic. Thank you.
Okay, thanks, Graham. That's really, really interesting. So in terms of what we learned, both Dominic and Graham have shared some of their findings, what they've learned, but I guess the overall thing is it doesn't work yet. Okay, so there's a lot that we did get working, and there's obviously a few things that we couldn't get working. And please bear in mind this session title is called a science experiment. So there is plenty more we could do in terms of applying some more AWS methodologies to either the networking or however we want to go. So Dominic obviously had issues getting a kind of an image prepared using the existing tooling, and Graham's obviously mentioned a series of challenges around networking and so on. But whilst there is still more to do, all right, we will continue to work on it. But I guess the main thing about the whole project that you've heard from both is that it was interesting to just try, and it was pretty fun just trying to get something going. So in terms of what's next, right? So look, sometimes solutions start with just trying something out, seeing what works, what doesn't work, and then we go from there. both Graham and Dominic have shared links to their work, so feel free to take a look at those projects. You can learn from them, maybe perform your own testing and your own science experiments at home, which leads us to the next thing, right? So if Harvester, AWS, and Linux are your thing, then we need you, right? So what interest is there in getting SUSE Virtualization working on AWS? Again, I'll repeat that official AWS support for SUSE Virtualization or the Harvester project isn't currently on our roadmap. But if you want to influence this, then please get in touch if you've got a good use case. All right. If SUSE Virtualization on AWS being supported would help you, again, let us know. And if you do decide to have a go over the coming months, then please feel free to share your experience. All right. So maybe for SUSECon 26, it could be you doing this session and seeing how far you got. Maybe sharing some details on your journey. And of course, if there's anyone from SUSE Engineering that's listening, then there's always a good Hack Week project to be had later in the year. I guess for now, a reminder, okay, if we haven't been clear, this is not currently supported on AWS, so please do not try and run your production SUSE virtualization clusters on AWS, all right? But if you do fancy the challenge, then please go and experiment and do share those results as well. So as I always say, if you have got this far in the session, then thanks for listening. I hope you found some of the content both useful and interesting. I'd also like to take this opportunity to thank both Dominic and Graham, who pretty much did all the heavy lifting to try and make this session a reality. So please enjoy the rest of the SUSECon content, and we'll see you next time.